to make everybody happy.
She has to bring others down to make herself feel better.
No, I don't get brings Cicely down. I don't want her to have anything.
Alright, so we're starting to get into what's actually my favorite part. We're going to do the algebra behind it first. It's not my favorite part, but then we're going to start comparing, like, okay, I've got an original graph, a derivative graph, a second derivative graph. Can I look at this and figure out what's going on there? Can I look at this and figure out what's going on there? And start going back and forth between them and figure out what they all mean. So we're starting with, this is the title, increasing, decreasing. So, if f prime of x is positive, then f of x has a blank slope, and f of x is blank. Or Kyle fill in the first one. If f prime of x is greater than 0, then f of x has what kind of slope? Positive or negative? Positive. The derivative tells you the slope. So the derivative is positive. It tells you the slope of the level above it. So if your first derivative is positive, the level above that is your original. That means that is a positive slope. We're going to carry that down a level too. If your second derivative is positive, that means your first derivative has a positive slope. So we can do that at multiple levels. If f prime of x is positive, f of x has a positive slope. And therefore, f of x is increasing. So we talked about this some before. Positive and increasing are two different words. Like, my bank account is positive, but when I pay my bills, it is not increasing. You know?
Positive slope means increasing.
Positive slope means increasing. Yeah.
But f of x could be a negative number, but it's getting closer to 0.
Yes. So, like, if you're in debt and you're paying off your debt, that's increasing. It's a negative number. Alright, so then the opposite is true also. So if f prime is less than 0, f of x has a negative slope. And f of x is decreasing. Like the shorthand version of it. Just rewriting the same stuff, just in a shorter way. I'll write that on the board too. That's pretty major. So I have one of my markers with like a little edge of So we're going to do this algebraically first, and then we're going to get into, like, I'll just give you a derivative graph and ask you to tell me some stuff about the original. That's not today. Let's look at the example. I'm just going to do this problems from here, for example, instead of making up my own. I just put extras on here. So let's look at number 1. Sorry, go back to your notes. Forgot something. Critical points. They're critical. You need to know about them. Critical points are where the derivative is 0. 0 or undefined. So basically, where top or bottom equals 0, because at the bottom is 0, that's undefined, right? So if the top or the bottom equals 0, that's a critical point. And that is a potential change of graph shape. It doesn't necessarily mean it is, and we haven't even talked about all the ways it could change. There's concavity too. But that's like the first spot you look to see if there's something going on. Alright, now go to the problem. Did I leave that there long enough? People write it. Good.
It's just a potential change of graph shape.
Yeah. So if we go to the problem, I'm great. Caleb, are you good? I'm going to find critical points first. So I'm going to take the derivative and set the top and bottom equal to 0. Most of the ones in here actually, well, no, there's some of them. So I'm going to set the top and bottom equal to 0. Some of them don't have a bottom. So let's go f prime of t, so that'd be 3t squared minus 12t plus 9. And the 2 goes away, right? I want to set that equal to 0 to find my critical points. These are points where something might happen. And I'll tell you what the x's are going to be looking at the graph. 1 is going to be a critical point, and so is 3. Because the graph changed from going up to going down, and then from going down to going up. So I can tell by looking at the graph. But you have to know how to do it without the graph too. So set this equal to 0. What can I factor out of all 3 of those? So that would give me t squared minus 4t plus 3 equals 0. And then I can factor that. So what multiplies to be 3 and adds up to be negative 4? Negative 3 and negative 1. Then I set those pieces equal to 0 and get my solution. So if I set 3 equal to 0, what does that give me? Nothing. 3 never equals 0. T minus 3 equals 0 gives me t equals 3. T minus 1 equals 0 gives me t equals 1. So those are your 2 critical points. What you're going to do from there is you're thinking of a number line. The AP test doesn't want you to write a number line, but you're kind of thinking of a number line. Like if I have this giant number line and I put a 1 and a 3, how many pieces does that split the number line up into? 3 pieces, right? The first piece is from negative infinity all the way to 1. Second piece is from 1 to 3. The third piece is from 3 to positive infinity. So you're like visualizing the number line, and you can write it if you want, but you can't like use it for your work. So then what I want to do is write out those 3 intervals. Like I can go over here on the side and be like, okay, that helps me realize like what's going on there.
Are we ever going to use like brackets or anything, or is it always going to be parentheses?
It's always going to be parentheses because at t equals 1 and at t equals 3, what's the value of the derivative?
0.
It's 0. So that's a different deal than what we're looking at.
We do also value things like x's plus x's.
Yeah, you like those, don't you? Yeah, you can. That's like hard for me for some reason.
So
But
yeah, always going to be x less than 1, x's plus 1.
greater than 1 but less than 3.
Yeah, greater than or less than 3.
X is greater than 3. Yeah, that's fine. Alright, now every spot in this range, it's either increasing or decreasing the whole time. It only can change at critical points. So whatever value I pick in here, if I find the slope is positive, let's say, that means the slope is positive for every point in there. Because it can only change at 1 or at 3. It doesn't even have to change there, but that's one place it could change. So what I'm going to do is pick any point I want between negative infinity and 1. And plug it in. If I want to find the slope, where do I plug in? Plug into the derivative. I want to know the slope. Derivative tells me slope, so I'm going to pick any number between negative infinity and 1. Plug it into the derivative. I'm going to pick 0. So I'm going to find f prime of 0. So the easiest thing for me to look at there is probably this top thing. If I plug in 0 there, all I care about is a positive or negative number. So it's 9, right? But the 9 isn't really the important part. F prime of 0 is positive. That's what really matters. Which means f of x is doing what? Increasing. Do the same thing for between 1 and 3. So I'm going to pick 2. You can't pick 1, you can't pick 3, because what would those both give you? They both give you 0. You can pick 1.73 if you want, but I think 2 is the easiest. Now for 2, I could plug into the top one, but I think like this is probably an easier spot for me to plug in. So 2 minus 3, positive or negative? Negative. 2 minus 1, positive or negative? Positive. So I got a positive times a negative times a positive. What's that? Negative. So f prime of 2 is negative, which means f of x is decreasing. Do the last one.
That's like a gross fucking.
What'd you plug in, Wilmer? So if I plug in 4, that's positive, that's positive, that's positive. F of x is increasing. So you have basically answered the question. I'm going to throw in some more while we're at it. I'm going to do 2 lessons at once. So, go back to your notes. Kyle, you have a question?
No, I think it would be.
Well, I want to know what the, like, I want to answer it if there's any question.
Why do you say x instead of the number that you plugged in? Just because that's
What do you mean? So, like, why have I put f of x increasing here?
yeah.
So 4 is just like a representative from the entire group 3 to infinity. So I could choose any number in there, plug into the derivative, they will all come out positive. So I don't care which one it is. I'm just showing that I used 4, and then it came out positive. I could use 5, I could use 9 million, it doesn't matter. It cannot change in between these numbers, so I pick anyone I want, and that's like a representative for the whole group. Is that what you're asking? Yeah.
So would we write it like that? Like f of x increasing, f of x decreasing, f of x increasing?
Yeah, and we're not done, we got more to write, but yeah.
Okay.
So the AP question could very well say, here's your equation, tell me where f of x is decreasing. That's a very common AP question. Then you would then do multiple choice and you would pick the 1 to 3. Yeah. Okay. Relative extrema. Relative min. Run out of room. I'm writing the same thing, I just need to write smaller. Relative extrema. Relative min. So if I have a min, it's like the bottom of a hill, right? So you're gonna have this point down there as a minimum, as a relative min. It's smaller than everything around it. So on either side, like you're at the bottom of a hill. F of x over here compared to over here what was the change? We changed from f of x decreasing to increasing. That means f prime of x changes from what to what? If f is decreasing, f prime is negative. That's different. So f prime is the slope. So I could just easily write slope changes from. These are the same thing. From negative to positive. So then relative x. I'm going to assume you can probably write your own notes on this one, but I'll do it anyways. So that's the top of a hill. So f of x changes from increasing to decreasing, and you will very often be asked to justify. So, like, find the relative max and justify that it's a relative max, and this is what you're looking at. So, like, f prime changed from this to this. And then what's another word for f prime? Slope. I don't really want to rewrite that whole thing. Is that okay? Okay. Question on this part. Now I'll go back to the problem again. Sorry. Okay, there is a change here from increasing to decreasing. Where did that change happen? At what x value did that change take place? At x equals 1. So prior to 1, you can see in the graph, that's the top of the hill, right? Prior to the 1 to 1, our derivative was positive, so f of x is increasing. And then we went derivative negative, so decreasing. So there's a relative what at x equals 1? Max. Could you tell me that without the graph? I mean, you can see in the graph, right? But you also should be able to go, okay, increasing to decreasing, that's max. And then decreasing to increasing, that would be a relative min at x equals 3. Now those two aren't going to be on your answer sheet. I'm kind of doing multiple lessons in one here, but I'll put them on there, like on my own, and we'll talk about them tomorrow and make sure they're good. I don't think that's the hard part. I don't think much of this is too bad, actually. Questions on that one? Like, we're done. So you've answered 2 questions. Where is it increasing and decreasing? And where are their relative max and relative min? The directions also say to address where there's discontinuities. Are there any discontinuities in this? Discontinuity would be like vertical asymptote mostly. At the bottom equals 0. We'll do one of those in a second. So let's do number 2. Then we'll find one with the vertical asymptote. We'll do that. Okay, so f prime of x, 1/2, leave the 6w plus 30, 1/3, leave the 6w plus 30 to the negative 2/3 times 6. What? You thought you were done with what? Derivatives? Jeez.
Yeah, I feel like are derivatives ever gonna end?
No.
So like anything else in there
There is no end to this.
There's
integrals, which is backwards derivative.
yeah. First semester we'll do derivatives, second semester we do integrals. But integrals are derivatives backwards, so we're still basically doing derivatives.
That's just
It's the same stuff you use calc 2 and calc 3.
So isn't this 2 over 6w plus 30 to the 2/3? So this is exactly why had you guys like get rid of negative exponents because so often your job is set the top and the bottom equal to 0. So I was forcing you to create a top and a bottom so that you can set them equal to 0. So like we got a lot of that work out of the way early, and so now we can go a little faster. So set the top equal to 0. When does that happen? Never. Set the bottom equal to 0. And do you guys know that power is completely irrelevant? So if I raise both sides of the 3/2 power, it would cancel here. And what's 0 to the 3/2 power? 0. So you can just erase the power. Because when you do that to the 0, it would just go away anyways. So 6w plus 30 equals 0, so w equals -5. That's your critical point. Something may or may not happen there. We don't know yet. But that's an important point. So we got the big number line. We got 1 point on the number line. How many intervals are we going to have? 2. So we're going from negative infinity up to -5. And from -5 up to infinity. And I'm going to pick a representative point from each section. Plug it into where? The derivative. Why am I plugging in the derivative? Because I want to know slope. So let's say I plug in like -10. Watch me do this. So I'm going to plug in -10. So now think about putting a -10 in for W. What's 6 times -10? -60. Plus 30. -30. Now I'm going to take the third root of it, but I don't really care what the number is. I have a negative number. The third root of a negative number. Is that positive or negative? Negative. Because if I started positive, when positive times positive times positive, I can't end up negative, right? If I start negative, 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 two of those go away and you got one negative. So, when I take the third root, yeah, I shouldn't flip it up. I gotta do 1, 2, something. That's negative. But then what am I gonna do? I'm gonna square it. So how's that done? Ends up positive. So f prime of -10 or -9 or -1,000,000 or negative whatever I picked is gonna be positive. Which means what is f of x doing? Increasing during that time. And if you look at the graph, so -5 is here. So we are increasing from negative infinity up to -5. And then we're going to be increasing after too, because I don't really care what I start with in the parentheses. I'm going to square everything at the end, so it doesn't matter what I plug in, it's going to end up positive, right? So let's say I plug in 0. Well, 0 plus 30 is 30. The third root of a positive is a positive, and a positive squared is still a positive. So then your derivative is positive there too. F of x is increasing there also. And we're then going to look for relative max or mins. Well, to be a relative max or min, it has to switch. It has to switch from going down to up, so you're at the bottom of the hill, or up to down, so you're at the top of the hill. Do either of those happen here? No. So you're going to say there's no relative. You could say extrema or you could say maximum. Extreme is a cooler word. So we switched from increasing to increasing. Something did happen there, and it's a concavity switch, which we'll get into soon enough, possibly tomorrow. We'll see. Question on that guy? Let's do this. Find the first question that has a vertical asymptote. 6, how do you know?
Because it's a dotted line.
How do you know by looking at the equation? There's a fraction, right? So there's going to be a vertical asymptote. Alright, so let's do this one. How do you know? Well, because I can see a freaking vertical asymptote. Alright. Take the derivative. You do it. In a second. Doing too much work. Sweating. You guys want me to show you again?
Good. everybody on YouTube. Look at my smile.
All one of my viewers.
Steven.
Yeah.
Does he still?
I don't even think so. I have like 0.2 viewers.
I watch them sometimes.
No, you don't.
Back to review.
No, you don't. You should do your homework.
I do sometimes. Sometimes I
So change to X. I'm gonna change to X because S's suck.
Why is it so blurry? Misses are fine.
That's why I changed. Is that 9 over X plus 3 squared? Is that what you guys got? So that's just close rule. Which node doesn't go away? Sorry. Okay, so I want to set the top and the bottom equal to 0. So similar to the last one, when I set the top equal to 0, that's useless. There's no critical points. It's possible there'll be no critical points. If there's no critical points, how many intervals do you have? 1, and what is that interval? Negative infinity to infinity. That would mean it's either always increasing or always decreasing. So, for example, a line. Like if I have y equals 3x plus 7, what's the derivative of 3x plus 7? 3. Set that equal to 0, what do you get? Can't solve it, right? So there's no critical points. But then the derivative is positive, so it's just always positive. So that could happen too. Alright. Set the bottom equal to 0, what do we get? Square doesn't matter. So x plus 3 equals 0, so x equals negative 3. Okay. So, that is my split. I'll have 1 point on the number line, so I'm going to have 2 intervals, right? So negative infinity up to negative 3. And negative 3 up to infinity. Pick a representative point from each interval. So let's say negative 5 here. Doesn't really matter. This is my derivative. So the top is always positive, and isn't the bottom always positive too? I think necessarily. It's squared, right? So no matter what I plug in, it's going to be positive. So like negative 5 plus 3 is negative 2, but negative 2 squared is 4. So in both of these cases, your derivative is positive, which means f of x is doing what? Increasing. And for a couple things. Oh, wait a second. So, is there a relative max or a relative min? No. And if I asked you why, there's actually an answer that you might not have thought of yet. One reason why there's not is because we didn't switch, right? But I'll say even if it switched, even if this was ink and this was deke, that would not be a relative max or a relative min. Why? So let's say this was f of x increases and this was f of x decreases. Typically that would mean relative which. If this was, it's not, but if this was ink and this was deke, that would be typically a relative max, right? In this case it would not be. Why?
Because it wouldn't exist.
Yeah. Can you have so relative max is a point that's at the top of like a hill. Can I have a point at x equals negative 3 on this graph? No, because it's vertical asymptote. So vertical asymptote like overrules relative max max relative min. You can't be a point that is higher than the other points if you're not a freaking point to begin with. Does that make sense what I'm saying?
Yeah.
Sorry for cussing. Control. So this one we're done. No, I'm just kidding. So no relative extreme. And we're good.
It's gonna be a great video today.
And I'm pretty sure that I've gone through like one of all the types that are on here.
And do we have to say this?
Oh yeah, so you should say vertical asymptote at x equals -3. Sorry, thank you. Or at least say discontinuity, but vertical asymptote's more correct, more
You just
specific.
know that because the fraction, if you set the bottom equal to 0.
Yes. I know it's the graph too, but you won't have the graph on the left.
Oh, right.
So yeah, the first step of this is you do these problems with the graph next to you so you can kind of see what's happening, and then I'm going to take away the graph. Then what I'm going to do is give you an equation. Like I'm going to give you this, and your job is going to be to create this graph
Oh, no.
without ever using your calculator.
What?
I think it's my favorite part.
I was actually gonna ask if you would have to draw that.
Yep.
That's like the first one.
No, it's not bad. Okay, so you have a bunch of points or a bunch of problems in front of you. You got 15. I did 3 of them, so you got 12. I'd say give me 6. You do 6 of them, I'll consider you having your homework done.
6 more.
6 more. Yeah, you don't get to count the ones I did. 6 more, your homework is done. If you feel like you need more practice, keep going. And again, I'm leaving you time so you can work. Please use that